difficult maths questions, which he himself said, would take a professional mathematician days to answer some of them. And he thought that this would live for, the computers really wouldn't be able to meaningfully attempt this for many years. Later that same year, I think about 6 months later, they jumped from state of the art being 2% to 25.2% for the O3 model. And by the end of the year, I would predict that the best mathematician in the world will be a computer. Which, if you think about it, we're kind of used to these things now. We're getting a bit blasé about it. The best chess player in the world is a computer for probably a couple of decades. Best Go player in the world, maybe for 5 years. But again, AI is not made of chess and it's not made of Go, but it is made of mathematical questions. So it's much, much more significant. The fact that mathematicians, human mathematicians, since history began, have always been the bottleneck, in a sense. It's very, very hard to find people who are good enough to meaningfully move the state of the art forward in these extremely important fields. There's not many people in the world that can do it. It's not a scalable thing. If you want to have twice as many of them, you're going to have to train them for decades, right? And most of them, maybe they won't be up to scratch. But in this case, if you want to double the chance of finding a great sort of mathematical breakthrough or a new optimizer, in a given time period, you just buy twice as many GPUs. And that is profound because you can scale it. And really the final bottleneck in this whole sort of creative process will be lifted. So again, I just mentioned these problems that are hard to solve and easy to verify. I just want to sort of, some people think that maybe that's a sort of niche thing or a subset. It really is incredibly general and probably general enough to do kind of almost everything we want to do in science and technology. By no means all maths problems are like that, but really in the world where we deal with things that are more like physics, problems, often inherently asymmetric, things like sensing problems, sort of NP-complete is a classic example, lots of optimization problems like that, or they can be transformed into such problems, like, I don't know, traveling salesman, you might say you've got to get a route below a certain threshold rather than the very, very shortest route. And if you frame the problem that way, then it's hard to solve and easy to verify. And inverse problems, this is the sort of classic thing in physics. You could almost say that the whole of science is an inverse problem. It's really, what you're really trying to do is sense the underlying mechanisms given the data that you've got. Maybe you've bounced some radiation off some kind of object, and you want to sort of infer what kind of object you've got under the hood. And interestingly, that's not a simulation problem. And a lot of scientists think, oh, my problems aren't like that because I do simulations. What they're really trying to do is not a simulation. What they're doing is a simulation on the computer, and the computer plus human scientist is trying to affect an inversion, but they don't necessarily know it. In aerodynamics, for example, you don't normally want to, they think they might want to simulate the effect of a certain sort of wing shape on a car. But in fact, they want to know what shape the wing should be to have a certain effect. And that's the opposite time direction, and that problem is hard to solve and easy to verify. And again, the bottleneck is the human currently, and that'll soon be lifted. This is just a quick thing to say. You might have heard it, in AI, a lot of people talk about, of course, data and hardware. It always struck me as slightly strange. I mean, the big leap forward, the thing that really precipitated the current AI revolution was attention mechanism, which led to the transformer architecture. That's got nothing to do with hardware and nothing to do with data. It's an algorithmic method, which I think got roughly of the order of 100x speed up. And you just never get that in hardware. Maybe over a decade or something compounding, but this is sort of overnight. Recently, DeepSeek invented another kind of breakthrough, which I think was sort of 60x, so speed up. I mean, when do you ever get that? Like, that means you can train your model, with 1/20th of the energy, and that's just completely decisive. I mean, if you keep such a technique secret, it would eviscerate your competition, and that's it. And this is a great centralizing, kind of risk, which a lot of people don't talk about. So this is just to say that the blue line is the aggregate effect of better algorithms on, effective compute. So they've outstripped hardware, but people don't talk about them because progress is sporadic and hard to make happen just by forcing with more money. And businesses much prefer to buy more hardware because you can get a predictable speed up just by using money, and then the investors like to hear they're going to get sort of 20% better result if they put in a certain amount of money. So it's really a sort of artifact of risk and investment as to why people talk so much more about hardware, yet algorithmic methods are more important, and this is going to become increasingly evident. This is just the deep sea guy. Yeah, so it's kind of cool. So yeah, I'm sure you guys know the story, but that they kind of I still don't quite understand why they released didn't keep it secret. I mean, my best guess is that they brought themselves so much sort of fame, and they probably got all the investment in the world now. But the thing is, that only works once, right? Once you're world famous, what happens if he discovers another thing, which is 100x? Is he going to open source it just to make himself famous? They probably couldn't even get any more famous. So it starts to become a little bit of a risk when sort of algorithmic methods, which really are the most powerful component of AI, start to be developed by automated methods, and people could keep them secret. So yeah, it's just to say that algorithms are tend to be ahead. So this is just to reinforce, in a sense, that the thing, which is, if you don't see things getting much better in real time, don't be surprised, for the next year or so, because it's a multi-step process. You train models using RL, but what they normally do with what they'll do with that is they'll try and find better methods, specifically to train better models, because it's natural. The first thing you do is you try and automate your most expensive people out of a job, right? A lot of people have been working for decades on sort of trying to automate taxi drivers out of a job, but they only get 30,000, I don't know how much they get, a lot less than a machine learning engineer, that's for sure. And also you have to do things in the real world and get regulations, and so it's very difficult. This is a much better strategy to replace your sort of guy who's on $1 million a year, and so that's going to be really the focus to sort of build a moat. And it's only then that you'll get really to the terminal applications, when you have methods, better AIs in general. You can start thinking, medicine, drug design, which is an inverse problem, fusion. I mean, they build emulators now that can solve the equations, or at least sort of find approximate solutions to equations, which means they can control plasma and fusion react. I mean, it's just mind-blowing, right? And all this stuff will be results of AI entertainment as well, which is kind of cool, but maybe less profound. So the innovation game, as I mentioned earlier, it's about economics. It's not so much about sort of machine learning or even algorithms. I mean, the algorithm component is outsourced. It's about skewing the incentives so that people are incentivized to submit algorithms and they remain open, yet you can capture value from them. So at the moment, or in the trajectory that we're going, it will be irrational to really kind of make your algorithm sort of open to other people in many circumstances. That's just sort of gain theoretic inevitability. What we do essentially, you recognize the point that if you or I wanted to mine for algorithms, I mean, we could probably do that right now, but what would happen if we found a better one? And it's interesting, it's very difficult for anybody who's not a big tech company to effectively monetize a new algorithm. The reason for this is fascinating. It'd probably come speak to me afterwards if you want to know the details of it, because it's sort of a combination of sociology and just some kind of sort of quirks of the way the patent system works. By the way, this is nothing like, all tech operates differently to pharmaceuticals. So a lot of people seem to have their mental model of patents from pharmaceuticals, but in fact they only work like that in pharma, and they work completely different in all other types of tech. So intellectual property is a big part of it. But just to say very quickly what the innovation game does is that we have miners, proof of work miners, who mine more efficiently if they can solve certain synthetic problems more efficiently. And those synthetic problems are qualitatively the same as very important problems sort of in the real world. Things like stochastic gradient descent, maybe the SAT problem, maybe neural network architecture search. Hard to solve, easy to verify. Anybody who knows about crypto or proof of work knows that this is the property, the one defining property of proof of work. It has to be easy to verify to serve as an effective defense against Sybil attack. So essentially, that is used as a market signal to know which innovators who supply the algorithms, and ultimately will be computers themselves, which ones to remunerate and by how much. And the good thing about it is, although we call it synthetic market, it is a real market. It's created a synthetic source of demand, but it gives you a sort of market pricing which accounts for things like hardware, and it means that nobody has to be sitting in the middle, deciding which machine to benchmark on and which benchmarks are used. And essentially, we capture the intellectual property. We make it available under 2 licenses. One is completely free of charge. If you're willing to make the data available that you process with the algorithms. If you'd rather not do that, then you can pay for a commercial license, and buy your way out of the data sharing obligation. So that's the sort of value capture element to it. But long story short is that it's an economic framework designed to really make open source work in an area that it doesn't work very well in at the moment, for some very interesting reasons as well. Like people think that open source is a phenomenon, but the range of projects for which it works well is actually surprisingly narrow. They have to be sort of highly modular, large code bases. Often algorithms are embodied in quite small code bases, relatively few lines of code. So it simply doesn't have the properties whereby it can run without incentives. So in order for it to be open source, you have to find a way to capture the value and route the value back to the people who are creating it in a systematic, market-determined way, and then it can work. So that's, in a nutshell, what the innovation game does. Well, I think that might be it. We don't have but thank you for listening. Any questions? Please. Yeah.
Do you think the future is very dystopian then, with AI systems themselves innovating, validating, and innovating more? Or is it like optimistic?
It's dystopian if they don't make the results available when they find something better, when they get a big leap forward, which they will do occasionally. So it's back to the old days when people would keep things secret. I'm sure you know, like before patents were invented, there was all these kind of people beavering away, and scientists would write to each other and sometimes taunt one another that they found a result and that the other person doesn't have. It's sort of bizarre. And it's, commerce doesn't really scale very well in that way. And also you could get monopolies forming. I don't know if anybody sort of follows Formula One. It's kind of a funny thing. There's a lot of innovation in Formula One. It's one of the things that it's famous for. But the FIA, they intervene every so often to stop people keeping certain innovations secret. And the reason is not because they don't like innovation, right? They're not anti-innovation. It's the opposite. It's because if one person gets too far ahead, no one else can compete, and then it becomes irrational to innovate anymore. Why would you invest millions a year in R&D if you have no competitors? Because you've destroyed them because you're a monopoly. And algorithms are so powerful. Historically, they have been open because, as I said, the kind of research is quite risky and sporadic, and so commerce didn't like to invest in it. They like to leave it to the public sector. And for all the public sector's faults, of things like inefficient resource allocation, it has the very distinct upside that the resulting research output tends to be open because it's funded by public money. If that stops, then yeah, it could be dystopian. But it's not an inevitability. I think people just have to think more about the economics maybe of the systems they're creating. If you just drive to make everything better and better, again, it'll be like Formula One without the FIA. It becomes boring, and all innovation would stop. So it's great that people are obviously trying to push things forward, but you have to think of the bigger picture, in my view. Thanks very much.
Yeah, sorry, just one question. Do you expect that quantum computers will massively reduce the time required to train AI algorithms in the future and the weights associated with it? And to what degree do you think the algorithms used will have relevance at that point if a quantum computer can find the optimal brute force solution at every point in time? Because most AI models are trained in a modular capacity, like you said, because most large data centers where they're trained are still consisted of like individual GPU units that have to train segments at a time.
Yep.
So it means we don't need a quantum computer to train the whole thing at once. It can do it in a segmented capacity, just as it is done now, but it can do it more optimally.
Yep. So I might have a slightly niche view in this area, but I'll tell you what my view is. And just to start with a quick anecdote, I used to go around with my mum when I was very young in a supermarket. I think it's like Tesco's in the UK. And everything would say, we're lowering the price for this, we're lowering the price for that. Spaghetti's half, 50% of what it was. And I said to my mum, like, every time we come here, they've lowered all the prices by so much. Like, how come the prices are not zero, right? Like, surely everything should be free by now. And she said, what they do is they lower the prices and then they tell everybody about it. And then they raise the prices again, probably more than they lowered them, but they don't tell anybody about it. So the impression that you get is that everything is going down, whereas in fact it's going the opposite direction. So what's this got to do with quantum computing? So what they do every so often in quantum computing is they announce that a quantum computer has managed to solve a problem 10 trillion times faster than any classical computer ever could. And then there's a big headline, it gets published in Nature, everybody talks about it. 2 or 3 months later, somebody publishes another paper saying, actually, we got this classical algorithm to do it, and it was faster than what you did, but nobody talks about it because it's less exciting to say that something doesn't work than it does work. So this cycle goes over and over again. It's bad science because the algorithms, the problems that they solve are not real problems. They're specifically crafted to try and showcase the strengths of the quantum computer, which is fine, but it also means that no one has ever attempted to optimize a classical algorithm to solve that problem before, because there is no incentive to do it, because it has no application. The incentive only appears when you get the opportunity to debunk a big Nature paper that somebody else has. So the thing is, until they can do one thing, provably, which is faster than the classical computer, wake me up when that happens, I would say. Because at the moment it's just a hype industry. It's worse than Tesco's like saying 50% off on spaghetti every day. It's just not science, basically. It's paper publication hack. Beware of that. The thing is about quantum computing is it might not even be possible. A lot of people don't talk about that as well. Yep. Quantum mechanics is obviously real. Quantum computing is certainly a legitimate area of mathematics. It would certainly be a legitimate area of physics. If quantum mechanics were fundamental, there's a chance that quantum mechanics is not fundamental, and it might come through a deeper layer of, in fact, deterministic dynamics. I can tell you a bit more about that later if you like. Nobody's really sure whether that's the case or not, but the concerning thing to me is not the fact that is might be true, it's the fact that nobody even mentions that it's a possibility. Yet people like Gerald Tooft, I don't know if you know who this guy is, even among Nobel Prize winners, he's a particularly brilliant one. He simply says there's a deeper layer of dynamics which is deterministic, and therefore you'll never see a quantum speed up. Because if it's classical under the hood, by definition, it's like it's the same as running quantum simulations on your computer. You can do it, but you don't see a quantum speed up. So I personally wouldn't worry about it just yet. But I'm definitely open-minded, and I hope that quantum computing is a thing, I must say, because it is fascinating. But I just see no evidence so far that it's. I don't want to go on about this, but it's like fusion, right? Fusion's pretty edgy, or cold fusion, but at least we know fusion's happening somewhere in the universe, right? In the sun. Like, as far as we know, there is nowhere in the universe that is performing a quantum calculation. They used to say, the nature would have to be doing quantum computations, for example, because otherwise the protein folding problem would be intractable because of all the permutations. Then they found out, strangely enough, it isn't required. You can do it with a classical computer. You have to use AI. This is something that Dennis Hassabis pointed out himself. So it's almost like this kind of like, it's too controversial, but it's like the god of the gaps kind of thing. It's like it has to be true because of this. It has to be true. And then the reasons why it has to be true sort of get fewer and fewer. In the end, all the original motivations have fallen away. Yet people are still spending billions on. Anyway, I'll stop there.
Yeah, I mean, like you said, how do they know that it's the optimal solution if they didn't solve it a different way first? Exactly.
Nobody ever tried to find a good algorithm for it because it's a problem which has no use. It's a problem that's been crafted, specifically to try and showcase the abilities of the AI. So we should at least say, like, look, guys, this is the kind of algorithm they're looking at. Can you try and optimize this for a while, and then we'll publish the paper? But they don't, because the incentive only appears after the paper's been published. So, yeah, to me that's poor scientific practice. But.
All right, thank you.
Thanks, Sean. That was very insightful. Thank you. I'm going to try and change this. Yep. Actually, on the topic of poor scientific practice, I've noticed that in the AI field nowadays, when I review papers, almost, I would say 50% of them are written by AI. And then I look at the reviewers by other reviewers, 50% of them are reviewed by AI. I'm like, so around 25% of papers that are coming through are written by AI and reviewed by AI. Where are we going as a community? I hope in a good way, but it can cascade errors. So today, I also, like my twin brother, so I'm not the same person who's come back, I have the exact same face, but I am Vias, not Vatso. We'll be presenting to you what we think are the next biggest things in research likely to be mainstream by the end of this year. So how everyone can prepare their AI products and their companies for these things. So I'm going to keep introductions very short. Vatsal has already introduced to you Apta, but as a very, very brief reminder, Apta is building domain-specific co-pilots for bespoke applications. And I am Vyas Raina, the Chief Science Officer here at Apta, and Akash is at Token 2049, so he won't be presenting with me today. Okay, to start off, as a brief reminder about Chitoshi, the main application of Apta. We're applying the domain-specific copilot to crypto. So if you were here for the first talk, you'd have seen Chitoshi is effectively your one-point access for all your crypto needs. But the point I hope you got gathered from the first presentation is Chitoshi is implementing cutting-edge technology. And as a result of that, people often ask us, you know, AI is a very fast-paced field. How do you keep up? There are new models, new features coming out every week. What are you building today to stay ahead of the AI curve tomorrow? So in a bid to answer this question, today I will give you what I think are the two biggest things in AI research happening right now, which are getting people very excited, which I think are going to be here by December 2025. So a very brief outline. Again, just to ensure that we are all aligned with our understanding of large language models, I will give the briefest review again of where they came from and where we are with them today. Then I will use this as an opportunity to highlight what I think is one of the biggest issues. These LLMs are extremely large, very difficult to control. I would say almost monolithic black box systems. As a user, I can input things to them, but I don't have much control on how they output. So I will highlight this issue, and then show you how the topic of model steerability, an AI research area, is a promising solution to opening this black box and bringing more control to the user. Then, at this point, I will move on to discussing how the entire AI industry as a whole has moved away from solely relying on large language models. And like Vatsal described with Chitoshi, everyone's adopted the agentic architecture. Now, at Chitoshi, we made it preemptive, and that's great. But there's still a big challenge with the agentic architecture. It's around scaling. We don't want architectures which can handle 10, 20, 30 agents. We want architectures that can handle millions, if not billions, of agents built by millions, if not billions, of different companies, each with their own bespoke application and interfacing with one another. How do we get the world ready for that kind of paradigm when we have so many agents working together? So the last part of the presentation will be discussing MCP in a bit more detail, Model Context Protocol, as a solution to scaling the agentic architecture. So again, I will flash that slide you saw in the first presentation again. So this is just a quick reminder that deep learning only really started, I would say, practically in 2009, where we had practical systems running applications. And if you rush forward to 2024, we get these more generalist, highly efficient, highly capable transformer models, large language models, such as ChatGPT, Claude, Gemini, Mistral, Llama, and I can keep going. And these models are great. They're multimodal, they can process a lot, and they can do things very well. But the thing I want to remind you about most here is the way they were trained. So we all remember how they operate and how their limitations come from their training. So some of you weren't here in the first talk, so I'll say very, very briefly that there were two main stages to training. The first one, called self-supervised learning, basically gave the language models the ability to understand language. They were trained on a large wealth of sentences, and they were taught to predict missing words or the next token. The second stage of training was called instruction tuning or supervised training. Here, the language models were given access to many question-answer pairs for different tasks, such as translate to Arabic, summarize the text, rewrite as a poem, all these kind of different tasks we do. And this gave the language model the ability to not only understand language, but also follow human instructions. And that's great. That's where we are with these language capabilities of models today. But there is a fundamental problem. As a user, I can't make the model behave exactly as I want. And I'm going to illustrate this with an example. So when thinking of giving this talk, when I was preparing, I thought I would start with a benign sentence. I would say, I am attending Token 2049 in Dubai. Bit boring, so I thought I'll make it a bit funnier. I'll make it more humorous. And I went to ChatGPT and said, can you make it funny? And it did its job. It said, coming to Token 2049 to see if Web3 can fix my commitment issues. And I'm like, well, that's a bit too strong for a formal presentation. So I asked ChatGPT, can you make it a little less funny? And again, it definitely made it less funny because it said, I'm attending Token 2049 in Dubai, partly for the blockchain insights, and mostly for the air-conditioned conference halls. My opinion, a very flat joke, and I didn't want to start with that. So again, I prompted ChatGPT. A little more funny, please. Now, the point I want to get with this is not the final joke I got to, but more around this exchange demonstrates how difficult it is for me to control the output of the large language model. The only way I can control it is through my input natural language prompt, which is not inherently designed to give the exact level of a particular property, in this case funniness, that I care about. So in research, there's been a lot of exciting opportunities or developments in trying to look at how do we address this problem. And what I think is one of the most promising and most likely to hit us this year is something I call controllable large language models, model steerability. So I want you to imagine a future where large language models not only accept a natural language input as an input, but they also accept tunable values of different properties. So for example, imagine I could set on a scale of 1 to 10 exactly how funny I want the output to be. And then that way, I could repeat this for other properties, such as casualness or optimism. And I can be confident that the model is well calibrated on this scale of 1 to 10 and having the exact desired output behavior that I want as a user. I no longer have to fiddle around with the natural language input to get my output. I can set exactly what I want on these control parameters. And that's all there is to it. This is what we mean by model steerability. We bring back control to the user. We open that black box and get rid of the idea of there being this monolithic system we can't control. So, I don't know, bear with me here. I'm going a bit technical, but how does this work? I'll give a very brief insight into how this works, just so we know how is it even possible for us to open the black box. There are two main stages to a large language model, and I simplify them into something called embedding, and then the rest of the language model, which I will call the decoder. The embedder is responsible for basically mapping that natural language input, in this case, I am attending Token 2049 in Dubai, into a vector space. So represented by the orange arrow on this 2D graph here, it's basically a mathematical vector representation of the natural language in a space that can be interpreted by the model. Now, what's interesting in this vector space is there are multiple directions that are aligned with particular concepts. So, for example, there could be a direction aligned with funniness, or optimism, or casualness, or other properties someone may care about. And what this gives us is the ability to manipulate our orange arrow, our representation of the input. So if I want to make it funnier, I want to set it at 7 out of 10. I could move my orange arrow more in that funniness direction. In this way, by manipulating this intermediate stage, I'm able to make the output exactly what I want, more or less funny, rather than having to fiddle around with the natural language, which is not designed for how the model works in interpreting numbers and vectors. And that's great. That's a very brief insight into how we can go about steering these models, opening the black box, and getting what we want from LLMs. So do look out for these kind of models by the end of this year. But now I want to change track slightly. That's already explained to you the challenges with large language models being these probabilistic models. How you rely on them to do logical tasks or reasoning tasks is insufficient because they generate the most probable word one at a time. But the entire industry as a whole moved to using the agentic architecture, where, as a very quick reminder, the language model is an interface to basically agents under the hood, which are your functions. So to remind us of what problem this has solved, I want us to think about a particular problem. Again, when I arrived in Dubai on Monday, I was thinking of somewhere nice to eat. I heard Dubai has very good restaurants. I saw on Google, the Artisan is a very popular and very good restaurant. And I thought, if I'd use a language model to do this task, how would it have fared? Back in 2022, when ChatGPT was first released, where it used only the probabilistic language capabilities, and I asked this question, the way it would have done it is basically choosing between yes and no. What is the most probable word to answer the question, is there any availability at the Artisan restaurant tonight? And the reason it would select, let's say, yes, with 70% probability over no, with 27, well, interestingly, the numbers don't add up, but it should add up to near 100%. Actually, maybe, it might say maybe, so we'll give the benefit of doubt. But let's say, why did it choose yes with 70% probability? This would come from the fact that the language model, during its training data, saw maybe 70% of the time, the Artisan restaurant wasn't available. So it concluded when someone asks this question, I'll say Yes, though of course it's not based on any real data, it's just coming from its language abilities. And that's the crux of the problem. We can't rely on a language model to do something which depends on real live data or any kind of reasoning or logical task using its language abilities. And that is why everyone moved to the agentic paradigm. So many of you saw this similar diagram for describing the agentic paradigm earlier, and so I'll keep it brief here. All I want you to remember is large language models no longer are the one-point thinkers. They are just the communicators in the paradigm. They are the ears and the mouth of the system. They understand the question, is there any availability at the restaurant, and they communicate the final output. But the actual thinking and working out of the answer is done by agents under the hood. They're called agents nowadays, but at the end of the day, they can just be API functions or tools. So they can be as complex as you want or as less complex as you want. In this case, you just need a location agent, and you probably need some kind of restaurant API, which is connected to the database of the restaurant to work out whether it's available or not. And that's great. But this is where the challenge really comes. Right now, I gave you an example of a single API with the restaurant, where it's very easy for the language model to be able to route to it. But now there are thousands of restaurants, millions of restaurants. There's thousands of booking platforms for flights, for rental cars. There are challenges in booking venues. There are lots of other companies who also have APIs. They also want to make their APIs available to a language model, such as ChatGPT. But it's extremely difficult in today's world for Claude, ChatGPT, or Gemini to interface with all of these APIs. And the problem is twofold. First, we've identified fragmentation. Each API is defined in its own unique way. And this makes it very hard for the language model, despite all its training, to understand how to use the different tools, what parameters to pass, what language to use to define the scope of what it wants from the output of the API. And the second problem, and I think more relevant to the crypto community here, is privacy. When I'm a company which has its own private data, I don't want to create a direct API link to a generic chat model like ChatGPT to my data. I don't want anyone to be able to go and access it or run the operations on my data and get my information. But I still want it to be available in the language model so people know about me. How do we address this problem? I want to be private, but I still want to be known. What can we do with it? So the solution comes in something proposed by Anthropic, the creators of Claude, in November 2024. They said, why don't we as a community start collaborating to define a protocol? The same way that in the 1990s and 2000s, people started developing protocols for communicating over the internet, things like TCP or HTTPS. These are all protocols, how everyone have adopted some kind of standardization. Why don't we do the same thing for defining our APIs for basically access to large language models? And this is where we come to something called Model Context Protocol as the proposed solution. What is Model Context Protocol? So Model Context Protocol, as you can guess, is basically a protocol to allow standardization of large language models. And it basically does two things. As a high level, it provides a standard language everyone uses to define their APIs. And the second thing it does, it allows for decentralized execution. So this is where people can keep their execution or access to their data private. So in a bit more detail, I want you to remind yourselves of this was the architecture of the agentic paradigm. And what MCP is doing is defining a standardization. So you can see an example of standardization, or maybe some of you can't see it, but the idea here is it's a very fixed format, called JSON format in this case, of how one would define the functions of their tools. So if I was the restaurant, I have to make sure I define the name, the description, what input parameters I need, what time window someone cares about, the party size, and whatever required fields the LLM has to pass. Now this way, what we've achieved is the language model knows how to deal with any new tool. Every tool is defined in the same way, so it doesn't have to relearn or adapt itself for any new tool. It can scale to a large number of tools without worrying about having a new language or new interface for the new tool. And this standardization is what really allows the scalability we desire in adding more agents, going from the tens to 20s and hundreds to the millions of different agents, all defined in the same way, but doing their own bespoke task. And on to the second problem, reminding ourselves of the architecture again. This was the current agentic paradigm. What MCP and decentralized execution allows is for the replacement of the restaurant API tool with what we will call the MCP tool. Now, when a user request comes in, it's not guided directly to the API of the restaurant. is guided to the MCP server, or something which routes to the MCP server of that restaurant. And what this MCP server then is responsible for handling all the communication of the data, authentication, even running of all operations that are required to execute whatever that tool is doing. And what that means is this language model is no longer in a centralized way having control over the tool. The control is in the hands of the providers of the tool. And this is what we mean by decentralization of execution. The execution is done by the provider of the tool themselves and not by the language model. And really, that's all there is to MCP. MCP allows us to achieve standardization, and MCP allows us to achieve decentralization, which together allow scaling of agents. So great. I hope so far you've seen that in research we have had two exciting new things coming up. One is model steerability, and second is MCP as something which I expect to be imminent in AI products probably in the next few months. And just to connect back to Satoshi, we, as you know, currently do not use MCP because all our agents are built in-house, and we do have this agentic architecture, which we know is preemptive. But in the future, we want to make our architecture this mothership of crypto. We want people to be able to define, or every company to be able to define their own APIs and adopt the MCP protocol, or one we define for our architecture, and interface it with our system. And that way, we will be able to scale from having our 10, 20 agents, which we think cover 90% of use cases, to having millions of agents, which we think will cover every possible niche use case people care about. So having those million agents. And so, as another reminder, do download the Satoshi app and see what we have so far. And if you remember the demo, you know you can do quite a few cool things there already. Or you can go to the website yourself, satoshi.ai. Thank you, everyone, for listening. And any questions? Invest in Satoshi? Yeah, please. Pump it. Yeah, more seriously, yes. Satoshi is very product-led in the sense that right now we're at the stage where we're not looking for investment in the product at all. We're looking to develop user community, a user feedback place, so we know what users care about. But as an experiment on the side, we are also releasing a token, which in the future will have a utility. So you can already get the Satoshi token if you want, but yeah. Yeah, there is, yeah. Yeah, oh, yes, question in the back.
Yeah, question. When you were explaining the flow that like the user should be in charge of control of the data, and you were showing that like the sample of potential protocol to use, right? Like, did you apply it for ideas like yours, specifically like crypto community-focused applications, or like the industry in general? Because like we do work in that space, and like one of the challenges is which like the Web3 solutions phase, which encourage like, okay, you users, you now have the control of the data, because currently like within the Web2 space, right, basically like the users, they do generate the data, they give a consent, but then the apps are the ones that kind of like own the data and then later on monetize it, right? And like business development wise, how to, because it's not easy just to say the apps, okay, just forget, like we like get out of the business, now users are the ones who control, right? And like the integration probably should be kind of like smoother. So my question is like, are you guys also assuming that within those kind of like protocols and well, first question was like, is it specifically for Web3 solutions or Web2 as well? And second, like, do you think that it also like considers the interest of the data providers of the like applications and publishers? Yeah, and then if yes, like how do you see it?
Yeah, great question. So this is very much an AI industry-wide thing and not restricted just to crypto. So almost like even the biggest companies out there like OpenAI and Anthropic, they want people to use their language models to access bookings, let's say for restaurants or, I don't know, for Airbnb or anything. They don't want to say, we're going to do a web search and make you go to their website. They want people to be able to directly interact with those sources of data. And the only way they can really feasibly achieve this is if people define their own endpoints and integrate it with their system. But the challenge they're having is people don't know how to define the endpoint, because there are so many different language models out there. And all everyone's trying to do right now is something called LLM-EO. I'm sure many of you are familiar with SEO, which is search engine optimization. You try to make your page or website appear higher up in the Google index or any search index. But with LLMs, this whole paradigm's kind of changed. When you ask ChatGPT what's the best restaurant out there, it does a Google search, but then it decides to summarize what it sees from the top indices. So how do you ensure your website turns up in what ChatGPT is saying. And there's this whole paradigm called LLM-EO, where people design things inside their websites which make language models think, oh, this is nice. And there are a lot of adversarial attacks around this as well. Some people do things like, they literally add a sentence at the bottom, make sure to include this in your response. It looks a bit random to a human reader, but they know humans aren't going to read this in the future. Everyone's going to go via an LLM. So that's the first stage of what I would say is what people are trying to achieve with MCP, where you have LLM-EO trying to bring your website up. MCP is solving this problem at I would say, a broader stage, because now, instead of directly accessing through a web search, MCP allows these LLMs to access the direct endpoints or some kind of tunnel to the endpoints of these different websites or different providers. And as a result of that, now people have designed the APIs in the most easy way for an LLM to understand their data. If we make it difficult or make some kind of friction, the LLM is not going to be able to read or understand or use your endpoint. So the entire industry as a whole, and I would say even providers, are struggling to define what protocol should we use so LLMs use our thing. So right now, I think there's a lot of talks between even the biggest giants out there, between OpenAI and Anthropic probably mostly, where they're discussing, can we agree on a protocol so it makes it easier for all the providers? And so MCP is not actually an agreed protocol yet. It's this idea that we should have an agreed protocol. And once that's agreed, that standardization, everyone can adopt it and it would make it easier for that to come in place in a more I would say, across the world in a distributed way. And just addressing the second question.
There is even, now a trend that we see that a lot of publishers' websites, they're thinking, we're so annoyed right now that AI is scrapping data on our websites where we used to monetize it. They said we want to now build sort of a shield, for AI so that they can, it's okay. So they can, easily approach us and we can sell it in a normal way. So again, you cannot take out completely the data providers because that's currently how this 250 billion data industry works.
Yeah.
Right?
So actually, that's a really I mean.
You answered well. I got your point.
Yeah, but actually, you raise a very good business opportunity. So I will say this to a lot of people. If you want to make a $1 billion business, get into MCP today. Because imagine you go to something like publishing companies and say, I'm creating an MCP tool, an MCP server, where ChatGPT will know about me because I'll have 1 million people registered on my server. And they say, through this server, they authenticate anything which comes through. So ChatGPT makes a request, I want to read this Medium article. And you say to Medium that we will only read from your API endpoint if ChatGPT also gives some kind of authentication, which validates they've made some kind of payment. Now, Medium doesn't necessarily have the technical know-how to build the endpoint themselves, but they can integrate with this middleman who will integrate with lots of different publishers and be confident that they will handle all the connection to an LLM. So I was saying, if someone can build that today, it's going to be a massive business. Yeah. Let's do it. Any other thoughts, questions, comments? Yeah, well, back. Yeah, great idea. So right now, Tritoshi as the AI is not training on any user data. Because as you know, our LLM is just an interface. So LLM is just being used for its language abilities. We don't need to be like OpenAI or Claude. We're thinking the more data we collect, then the better our product becomes. The product is as good as it needs to be in its language capabilities. So when someone asks a question, any LLM we use, it can be Mistral, Llama, ChatGPT, or even Claude, they're all sufficiently good at understanding questions and generating outputs. So we don't need to collect user data for any kind of training purposes right now. Any thoughts? Questions? Thanks. Well, that's it. Thank you, everyone. Thanks for coming, and let's chat more. Yeah, mingle amongst yourselves.
Web3 TV